Substrate pH is one of the most important nutritional parameters when growing plants. Hi, I'm Brian Whipker, a professor of floriculture at North Carolina State University. Today we will explore some of the visual symptoms of suboptimal pH. The pH affects the availability of nutrients in the substrate. The plant may be restricted in obtaining nutrients if the pH is not optimal. This illustration shows the relative availability of nutrients based on pH, from a low of 4.0 at the left to 8.0 at the right. The wider the bar, the more available the nutrient. As you can see, phosphorus becomes less available to the plant as the pH goes up, while calcium and magnesium are more available at higher pHs. Most micronutrients, which are colored purple, are less available as the pH increases, and high pH levels can result in deficiencies. Iron is the most commonly observed micronutrient deficiency. At low pH levels, micronutrient availability to the plant increases. This can lead to toxicity conditions. Toxicities of iron and manganese are often observed in plants. Optimal pH ranges vary by crop type. In greenhouse production, we generally classify plants into three groups. The low pH group, also referred to as the petunia group, prefer a pH range of 5.3 to 6.2. This group of plants commonly develops iron deficiency symptoms of intraveinochlorosis due to elevated pH levels. To prevent this from occurring, the substrate pH is maintained below 6.2. The next group of plants is the general group. These plants typically grow better at a pH range of 5.8 to 6.3. These plants are less likely to develop nutritional problems due to low or high pH. Finally, the last type is the high pH group, or sometimes be referred to as the geranium group. These plants are prone to developing micronutrient toxicity symptoms if the pH drifts too low. Therefore, the optimal range of growth is between 6.0 and 6.6 to prevent this from occurring. When nutrient symptoms appear due to pH, they typically develop either in the upper or lower foliage. The location of the symptoms provides a clue to what is occurring. Low pH symptoms typically appear in the older leaves, and high pH symptoms typically appear on the new growth. So now let's look at the symptoms of high pH. When the pH becomes too high, this can induce iron deficiency. The symptoms are intraveinochlorosis of the upper foliage, as seen here with the snapdragon. Classical intraveinochlorosis symptoms are clearly evident here with this scented geranium. The veins remain green while the tissue between the veins is yellow. Symptoms induced by high pH conditions follow a distinctive pattern. Initially, there's a slight intraveinochlorosis of the recently matured leaves as seen on the left. As symptoms progress, then the intraveinochlorosis becomes more pronounced and visible on other leaves. If the pH is not corrected, then the leaves can become completely bleached as seen on the right. Here is an example of advanced iron deficiency with complete bleaching of the new growth. This condition was induced because the substrate pH was too high. At the opposite end of the spectrum is low pH problems. They generally follow one of three patterns. The first type of symptom is bronzing or yellowing of the lower foliage, as seen on the geranium plant at the right. Over time, necrotic patches also develop. Marigolds are also a common plant in which bronzing is observed if the pH is too low. Here's an example of a unique situation. In this case, the lime was left out of the substrate mix. This resulted in a substrate pH near 3 and the leaves were yellow and the plant growth had stalled. Here is a close-up of the plants. The low pH situation is manifesting itself as a lower leaf loss and may be calcium deficiency of the new growth. Here's an example of the second type of low pH symptoms. Low pH problems can also appear as lower leaf black spots, as shown here with these nasturtiums. Black spotting also occurs on the lower leaves of Gerber if the pH is too low. This type of symptoms are also observed with dahlia, fuchsia, and pepper. Finally, wanted to bring to your attention a third situation when the pH is too low. In this case, with petunias, when the pH is too low, the plant does not exhibit any visible symptoms. Instead, plant growth is stunted. As you can see here with the plants on the right, when 10 pounds of lime was added per yard of substrate, the resulting pH was 5.1. Plant growth was normal. When the lime rate was decreased to 5 pounds per yard, the resulting plant growth was 29% less. This occurred when the pH was 4.8. The extreme occurs when no lime is added and the substrate pH is 3.3. This resulted in plants 59% smaller than when the pH was 5.1. Stunted growth due to low pH can be difficult to observe if the entire crop is smaller. It is almost invisible until you realize that the plant is not growing at its normal pace. A similar situation can be observed with these Viking red poinsettias grown at 3 substrate pH levels. At pH 2.9, the plants are visibly smaller and color development is delayed. Plant growth, though, at pH 4.7 and 6.0 were similar. So what is the take-home message? In summary, the optimal substrate pH ranges vary by plant type. The recommended ranges were developed to help avoid the onset of pH-induced nutritional problems. When the substrate pH is too high, interveinal chlorosis or yellowing can occur on the new growth. Low pH symptoms can vary and appear in 3 different forms: bronzing, black spots, or stunted growth. Therefore, visual symptoms are not always working in diagnosing low pH problems. The best method is to continually monitor the substrate pH to determine if the pH is within the optimal range. Thanks for watching this research update from the NC State Floriculture Program. Hope these results help you enhance your greenhouse's profitability. Until next time, keep growing your bottom line.